Hey guys, this video is going to describe anything that you might miss in class today on Friday, November 5th in 8th grade honors math. If you click on the async makeup work and recap, that should be where you're watching this video. I haven't filmed it yet, but it will be there by the time you see this. And you'll want to click this link to access the classwork. This is just a short to-do list to make sure that you know exactly what you need to take care of to make up today's classwork, and I'm going to walk you through it now. So the first thing that you need to take care of is the quiz, which is on slide 1 in Classkick. Make sure that in this quiz, you show your work. So you're not just telling me what x is equal to, but you're showing me the inverse operation. So what I would do is I would pause this video, finish the quiz, and then come back and unpause the video so I can walk you through the classwork. All right, you should have already taken the quiz. Let me show you what we're working on today. Lesson 5 is more about dilations in the coordinate plane. The first activity is 5.1, many dilations of a triangle. All of the triangles are dilations of triangle D, and they have the same center P, but different scale factors. What do triangles ABC have in common, and what do triangles EF and G have in common? And again, they're all dilations of triangle D. So go ahead and pause this video and write a full sentence for me answering these questions. So you might have noticed that triangles A, B, and C were all smaller than triangle D, whereas triangles E, F, and G were all larger than triangle D. And so one thing that's important to note is that because A, B, C, and D are larger, and I should separate those, A, B, and C are larger than triangle D, they have a greater area, and E, F, and G are larger. Whoops, I should have written A, B, and C are smaller, right? A, B, and C are smaller, and E, F, and G are larger. That means that the dilation to A, B, and C used a scale factor less than 1 because it created a smaller triangle, whereas the dilation to E, F, and G used a scale factor greater than 1 because it created a larger triangle. And I know this is something we've talked about already, but it's just important to note that when the scale factor is larger than 1, you know the shape is getting bigger. And when the scale factor is smaller than 1, you know the shape is getting smaller. So if you want to get these notes down, you can pause this video. And I'm going to introduce activity 3 and 4, or activity 2, but on slides 3 and 4, and you'll do that independently. So on slide 3, it tells you to draw the polygon AFID and dilate with the information below. So the first thing that we're going to need to do is actually create AFID by connecting the points A to F, and then we'll need to draw another line segment to connect F to I, and another line segment to connect A to D, and another line segment to connect D to I. So now we have the polygon AFID because it tells us here that that is the polygon we're dilating. And below, it gives us the information about how to dilate this polygon. Remember that the best way to dilate a polygon is to dilate each of the vertices or the corners, because dilating individual points is going to allow you to create a dilated shape. So we know the scale factor is 1/3. You'll dilate this shape. And then on slide 4, you'll do the same thing, but with ONPQ. So you'll have to connect some points and follow the directions below. Make sure you pay attention to the center of dilation. When you finish slides 3 and 4, you'll want to go back to Friday's main folder and complete the exit ticket. You can always rewind this video if you need any of these directions again. And I did post that to-do list in this page so that you can make sure you got everything done. As always, just send me an email if you have any questions.